Today we solve some capacitor numerical. Okay, so that's a very important in JEE and Neet exam. So there is a little bit difficult. So not only difficult, but there is a conceptual actually mainly. Okay, if you know the concept of series and parallel, how to solve the series capacitance problem and parallel capacitance problem, and that is a very easy then. Okay, otherwise a little bit difficult. So here we solve some basic numericals. Take an example. There is a voltage source V, and there is a capacitance C, a capacitor C1, and a capacitor C2, and there is another capacitor C3, and here is another capacitor C4. Okay, so see the diagram. That's a voltage source. The one terminal is much longer than other, means that is a positive terminal, other is a negative terminal. But in capacitor the two terminal have same length. Okay, means one side, any one side of positive and other side with a negative. Okay, so now to calculate or given data, so V given 9-volt voltage source and C1 C2 are 30 microfarad each, 30 and 30 microfarad. C3 and C4 are 15 microfarad each. 15 microfarad, here is the 15 microfarad each. Now calculate charge hold on C4, capacitor number 4. That's the question. And how to solve these? Okay, these type of numerical, the basic numerical. Okay, so first we see the diagram and analyze the combination, series and parallel combination. And if you see that the voltage source, now see that that is called open source. Suppose I source with the open, and we view from here, there's the open here. So from this side of view, so like that, if I open these, so now look like this. That's the C1, that's C2, that's C3, and that is C4, and C from here. This is I. Okay, and now we see that, and counting node here. So here we see there is a two node, one node and that is another node. And if you say that there is another node also. Now find the junction node. Find junction node. And how to find the junction node? So what terms define junction? Junction means there is a more than three branch or three paths are connected. Here this node is a junction node called J1. Suppose this is any name J1. These J1 with a junction because there is a one path, 2 and 3. Three paths are connected. Means more than two paths are connected. That node is called junction node. So more than two paths connected that node. So it's called junction node or junction point. Okay. And if you see that node is only two paths are connected, the path 1 and there is a path 2. So that's why these nodes are not a junction node, or these points are not a junction point. And you see that this point obviously a junction point because 1, 2, 3, three paths are connected. So that's why these are called a junction point. So you name that junction point with a J2. And here the 2 point here, and there is only one path. So that means these two are not a junction point. Okay, so J1 and J2 are the junction point, and the very important things that these two capacitors C4 and C3 are connected the junction 1 and junction 2 nodes, or junction 2, these 2 points. So that's why these two capacitors are parallel. Okay, they're very important. When capacitors are connected by two junction points, so these capacitors are called parallel capacitor. Parallel capacitor. Okay, that's called parallel capacitor. So you know that if these two are parallel capacitor, so now capacitor combination of these two capacitors C4 and C3. So combine these to get C34. There is a name, you can choose any. I think you choose X, Y, Z or anywhere. There is a name also. And choose as you wish. So C34 and we get these two. So you know that these are parallel. So that's why these two are added. So 15 plus 15 we get 30 microfarad. Okay, that's very important. So here you get 30 microfarad. Now the modify the diagram. Modify diagram now. The source here and that is C1, that is C2, another capacitor C3, 4 and we get 30 microfarad and this is also 30 microfarad and that is 30 microfarad and that is a 9 volt. Okay. Now calculating simple if these are circuit with the open. So if that is open, so if that is open. So now these three. So there is a no junction point. So that's why these three capacitors are in series. So total capacitance CT. So these three there is a no junction point here because these are connected too fast. These nodes are connected by too fast. So that's why there is a no junction point here. So that's why these three capacitors are a series connection. So that's why the total capacitance is get 1 by CT, that is 1 by C1 plus 1 by C2 plus 1 by C3 4. That means 30 LCM. So 1 plus 1 plus 1. 3 upon 30 and you get 110. The total capacitance is 10 microfarad. Now get the next page and now modify the diagram. So here that's the voltage source and there is a total capacitance CT that is equal to 30, 10 microfarad. 10 microfarad capacitance. The capacitor that is a 9 volt battery source. Now, if you wish to calculate a Q4, that's why in Q4, now you can calculate the charge hold by this capacitor. Very easy. Okay, that is Q. So the Q equal to CV, we know that. So get 10 into 9 microfarad. Sorry, here 9 microfarad means minus 6, and the unit is a coulomb. So 90 microcoulomb, the total charge. Okay. Now 90 microcoulomb are distributed by these four capacitors inside these four capacitors. Okay. So how to calculate that? Now here the important concept is series and parallel concept. Okay. The series and parallel concept. And you see that diagram. Before that diagram, here these three are in series connection. Now copy this diagram. Here these three are series. Okay. So here the series connection. So in series we know that the holding charge, the charge holding in each capacitor be same. Okay, so here the q amount of charge here, here also the q amount of charge, here also the q amount of charge. Okay, so now very important things is total combined we get the charge is same amount of charge, so 90 microcoulomb. Here is 90 microcoulomb, here is 90 microcoulomb, here is 90 microcoulomb. Capacitance value be the change, but the holding charge, holding of charge, Q holding in each capacitor be same is the concept, you know that. So now calculate potential of each capacitor. So here is a V1, suppose say that, okay, that is Q equal to CV, so V equal to Q by C, so 90 by 3, so you get 3 and micro cancel, so 3 volt, and V34, so that is a 90 by 3, sorry 30, so and you get also 3 volt, and here same V3, say that V3, and that is V34 and V3, that is equal to similar the 90 by 30, that is we get a 3 volt and micro with the cancel 3 volt. So each capacitor potential difference between two plate be the 3 volt. Okay, and here is another concept. Let's see the diagram here. Okay, now if you wish to calculate the charge holding on this C4 capacitor, first we want to find the potential drop across this point to that point. Now how to find that? So here in series we get all voltage. Okay, that is here 3 volt, here be the 3 volt, here be the 3 volt. So these 3 volt means potential drop across these to that point, either plus minus or minus plus, you don't know that. That is a 3 volt, either this plus, actually that is a plus minus, okay, or minus plus be the, that is 3 volt, either minus plus, okay. So mainly the concept that is 3 volt. So here that is 3 volt, and we know that in parallel there also the potential drop is 3 volt. In parallel all potential drop is the same. So these two line have 3 volt potential difference. Potential drop across C4 also that 3 volt, and C3 also that 3 volt. And we know that C4 that is equal to given 15 microfarad, and the potential with a 3 volt. Now calculate charge. So Q equal to CV. So here C 15 times 3 microcoulomb, 10 to minus 6 means microcoulomb. So that is a 45 microcoulomb. Okay, that's a very easy answer. The final answer is 45 microcoulomb. That's the answer. So one important concept is that in parallel potential difference be the same. So here the 3 volt, that is also the 3 volt. Okay, if I say that is a plus or minus, so that direction be the same 3 volt. So that will be the also same, that's a 3 volt. The final answer is 45 microcoulomb. Q equal to CB, so you get 40 microcoulomb. That is the main answer. Okay. Okay, clear the concept how to solve this type of capacitance problem. Okay, a capacitor problem, series and parallel combination. Now let's solve another similar type of numerical. Is the given is from Resnick Halliday book actually, and given a diagram. Suppose question number 2. Suppose diagram, there is a voltage source V, and that C1, C2, C3, C4, C5, C6. Okay, the 6 capacitor. So V given 12 volt and C1, C5, C6, 6 microfarad. So here given is C1 6 microfarad capacitance, C3 and C6, C1, C3, C6, C1, C3 and C6 are 6 microfarad. Okay, C2, C3, C4 are 4. C2 and C2, sorry, C5, sorry. That's C5 and 6. Okay, that's the 6. C2, C3, C4 are given 4 each. 4 microfarad, that is 4 microfarad, that is 4 microfarad each, and B is the 12 volt. So calculate total QT and calculate Q4. Okay, that's a very easy solving numerical. Okay, so how to solve that? So from previous concept, first we are calculating the series and parallel combination. Now voltage source is being removed. Okay, remove. Okay, now we see that diagram. Find the junction point. Okay, so here is a one junction point. There is another junction point. So there is another junction point. This is not a junction point. That is only two paths are connected. Junction point and junction point. There is a junction point. This is not a junction point here. Okay, so you see that C2, C3, C4 are all connected if these three junction points be the same point. These three are the same point. Suppose J1, J1 and J1. Okay, and these point be the J2, these point be the J2 and these point be the J3. So junction 1 and junction 2, between these two, from junction 1 and junction 2, there is 3 capacitor connected, C2, C3 and C4. So that's why these 3 are parallel. So total capacitance C2, 3, 4 is parallel. So they just be added, normally algebraically added. 4 means 12 microfarad. And C5 and C6 are connected J2 and J3 junction. So C5 and 6, these two obviously are parallel. So this must be added. So 6 plus 6 also you get a 12 microfarad. Now modify the diagram is C1 and here the another capacitor from junction 1 and junction 2, from junction 1 and junction 2, J1 and J2 here, that is C2, 3, 4 given 12 microfarad, and from junction 2 to junction 3, that is 12 microfarad, BC5, 6, 12 microfarad, and line these to join. Okay, now easy. And now we see that these three, C1, C2, 3, 4 and C5, 6, all three are connected in series because there is no junction point here, because that is a two path are connected. So that point is now not a junction point. Before that, that is a junction. Now that is not a junction point. That is also not a junction point. That is also not a junction point. So total capacitance, that is series. So just 1 by reciprocal of this are now added. So C1 be the 6. So 1 by 6 plus 1 by 12 plus 1 by 12 microfarad. So finally get a microfarad. Okay, put 10 to minus 6 microfarad. Put that is 12, 12, 12, that is 12, 2 plus 1 plus 1, that is 4. 4 by 12, so we get 1/3. So CT we get 3 microfarad. That's actually 1 by microfarad. Now we reciprocal that is at 3 microfarad. The total capacitance we get 3 microfarad. And V now is given here. So V now given 12 volt. So V equal to 12 volt, and so Q equal to CV, or here the Q total. So Q equal to CV, 12 times 3 microcoulomb, that is 36 microcoulomb. The first answer we get 36 microcoulomb. And next answer, charge hold on C4 capacitor. Okay, so how to solve that? So now calculate potential of each. So that is 12 volt. C1 given 6 microfarad. Okay, and charge hold 36 microcoulomb. Sorry, microcoulomb. Okay, so 36 hold of each, because they are three are in series, so that's why 36, 36, 36 microcoulomb, 36 microcoulomb. Here is 36 microcoulomb. So 6 divided 36, and you get 6 volt. It's 6 volt, and that is 12 divided 36, 36 divided by 12. Here is that, so 3 volt, and here also 3 volt. So get 3 plus 3 and 6 plus 6, 12. Okay, now our numerical be the okay. We check that 12 volt. That is also 12. So here you see that is junction 1 and junction 2. So C4 are connected, junction 1 and junction 2. So there is a parallel. So 3 volt each, 3 volt, 3 volt, 3 volt, because that is a parallel, and you know that in parallel the potential difference be the same. So junction, so now be the points J1 and J2, not call a junction, so that is J1 and J2 point. So that is 3 volt, so 3 volt each. So C2 have a 3 volt potential, C3 have 3 volt potential, C4 also have 3 volt potential. So V4, that is 3 volt. So what is Q? So Q equal to CV, C3 for the 12 microcoulomb. Okay, Q equal to CV, and we get 12 microcoulomb. That's our answer. Clear the concept? To share some basic key point, if I summarize the key concept, here. Key concept, solving this type of numerical. Okay, so the second numerical, there's the first numerical number 1. The key concept is that in series and parallel combination, okay, in series, holding charge in each capacitor be same. Even total capacitance, total charge hold in 3 capacitor, these also be the same. Okay, so that's why the all values be the same. Even the total charge of 3 capacitor be the same. Be the same. So first concept. Second concept, potential or voltage in parallel be same, not in series. Okay. And third point, find junction point. Find junction point. That's very important. If you find the junction point, so and capacitor connected by the J point or junction node are in parallel. That's very important. In junction point, capacitor are connected. That junction to point is connected in parallel. Okay, junction point. I know that what is junction point. Junction point means there is three paths or more than two paths actually. Suppose it is 1, 2, 3, 4. So these point be the junction point. But from that, this point is not a junction point. Okay. Then summary the key concept of solving capacitor series and parallel numerical. Okay, if you have any doubt, okay, so always ask in comment section, and comment section be the open for everyone. So solve this type of numerical. Okay, if you have any books, NCERT, Newton's or any other book, HC Verma or from Google's, okay, if solving this type of numerical, if you doubt if any numerical solving, if you face a solving that any doubt, you want to try to solve this, so always ask in comment section. Okay, I will try to give the answer. Today end the class here. Thank you.